class, let us continue our discussion of pipe problems. This time, we will discuss how pipelines that connect 3 or 4 reservoirs are computed, okay, are solved. So you are shown here, these figures here represent 3 reservoirs, okay, and this tube here, or a pipe, represents the piezometer. This is a piezometer tube that is connected at this point, the junction, where all the pipes leading to or coming from a reservoir is connected. So, ang tawag dito ay junction. Dito lahat nagmi-meet yung tatlong pipes that connect the 3 reservoir. And this piezometer here represents the energy at this point, at this junction. So, yung itong height na ito nagre-represent ng total energy at the junction J. So, you see here, the reservoir A is connected to a pipe 1 that leads to the junction J. So, with B, okay, pipe 2, reservoir C, pipe 3. Now, if this height represents the total energy at the junction, and the total energy at A is its elevation from the junction, connecting the surface of the water surface at A and the water surface in the piezometer, we form a sloping line. So this sloping line will indicate a vertical drop, which is the head loss along pipe 1. Then from the piezometer level to the water level at reservoir B will indicate the head loss, friction loss at pipe 2. From this level to this level, the vertical drop is HF3. Now, the basic property of a hydraulic the energy gradient is that it slopes downward to the direction of flow. So, if this slopes downward towards this, that means that the flow is from the reservoir to the junction. Then, from this point to this water surface, it slopes downward towards B. So, that means to say that from the junction, papunta sa reservoir B. Ganon din ito. Okay, sloping downward to the direction of flow, which is towards C. So, from the junction towards reservoir C. So, from this analysis of the 3 reservoir, we can say that yung reservoir or the pipe 1 is discharging towards pipes 2 and pipes 3. So, Q1 is equal to Q2 plus Q3. So, yung namang gagaling na flow from pipe 1, madidivide, may division of flow papunta sa pipe 2 na magdi-discharge towards B and pipe 3 na magdi-discharge towards C. So, yun ang ating conclusion that reservoir A supplies reservoirs B and C. Also, this graphical representation of the energies and the head losses will indicate that the head loss between reservoirs A and B is HA to B, which is HF1 plus HF2. Then, between A and C is HF1 plus HF3. Between B and C is HF3 minus HF2. So, we have how many equations? 1, 2, 3, and 4. Ito yung equation na sinasabi dun sa ating figure. Okay, another situation is illustrated here. Again, 3 reservoirs, A, B, and C, with the water surfaces elevation as indicated in the drawing. The pipes are 1, 2, and 3 and connects the reservoir towards the junction J. So, the pipes are connected in such a manner that nandito sila, they meet at a common point which we call the junction. Now, at the junction again is an illustration of a piezometer tube whose water surface is at this elevation. Okay, if we are going to draw graphically the energy gradient and the energy head loss, okay, from the water surface elevation at the piezometer and at A, it slopes downward towards the piezometer at J. Okay, and then itong water surface na to, slopes, pag kinonekta natin yung dalawang water surfaces, the line that is drawn is sloping downward towards J. Tapos mula dito hanggang doon sa C, sloping downward towards C. So what do we conclude with this kind of connections? So sloping downward from A towards this is the flow is from reservoir A towards the junction. Ganon din ito, papunta doon sa junction, so the direction of flow is from reservoir B towards the junction. So these two will supply, okay, mula dito sa junction towards C. So the flow is towards C. So yung arrow na yan, nagsasabi kung saan ang direction ng ating flow. So with these situations, with the drawing of our energy gradients, makikita natin that yung flow na nanggagaling sa pipe 1, okay, at na nanggagaling sa pipe 2, ay magko-combine para mag-supply sa pipe 3 papunta sa reservoir C. So that is one equation. And then the head losses can be determined. The total head loss between reservoirs A and B is HF1 minus HF2. The head loss between B and C can be determined from HF2 plus HF3. The head loss between A and C is the difference in elevation between A and C, which is HF1 plus HF3. So that is different from the first situation kanina. Okay? Now applying these principles, let's have a problem. Okay? So the lengths and diameters of the pipe connecting reservoir A to the junction, as well as the friction factor at pipe 1 are given. Ganon din para sa pipe 2 and then pipe 3. Now, the elevations of the water surfaces of A, 80. Elevation ng water surface at B is 70. Elevation ng water surface at C is 10. So, given lahat. So, kamukha lang din ito. So, ito yung gagamitin nating equation. That Q1 plus Q2 is equal to Q3. So, how much is Q1 and Q2 and what is the total discharge? Okay, so let's have a simple problem using the analysis we have given in the 3 reservoirs. So, you are shown here 3 reservoirs, A, B, and C. Connected to reservoir A is pipe 1 hanggang doon sa J. B is pipe 2. Connecting reservoir C to the junction is pipe 3. So all the lengths and the diameters of these 3 pipes are given, and we will use the friction factor of 0.02 for all the pipes. Now the elevations of the water surface of A and B are given. And A is discharging 1.35 cubic meter per second towards the junction. And from the junction, it discharges towards 2 and 3. So, yung ganito ang direction of the discharge. Nanggaling sa Q at nagsusupply sa dalawang pipes 2 and 3. The problem here is, ano ba yung elevation ng water surface at the reservoir C? Okay. So, using our discussion kung paano siya malalaman, the head loss. So, if this height represents the pressure at the junction, ito yung nagre-represent ng gaano kalakas yung presyon ng tubig dito sa junction na ito. So, ibig sabihin, mas mataas yung presyon ng tubig sa junction kaysa dun sa BNC, kaya siya yung nagsusupply. So, pag ganun yung direction of flow. So, this drop in the energy gradient represents HF1, okay? Mula dito hanggang doon sa junction, sa reservoir B, is HF2 along pipe 2, and then ito yung HF3 along pipe 3. So, we know here that the difference in elevation between A and B is 150 minus 144 is 6. So, kuhanin natin yung HF1. Okay? From this formula, alam natin yung F, L1, Q1, and D1. So, we can solve for HF1, 218. 2.18 meters ang HF1. So, with this value at HF1, malalaman na natin kung gaano yung energy. Yung energy at the junction J. So, elevation ng 150 minus HF1, yun ang elevation ng energy at the junction J, which is 147.82. Okay? Then, alam na natin, if this is 147.82 minus the elevation of the water surface here, 144, makukuha na natin yung HF2, which is 3.82. Now, 3.82 is HF2. Pag kinuha ulit natin ito, kinuha natin yung formula for the friction loss, 0.0826 F L Q2 over D2 to the fifth, we will know the value of Q2, 0.64. So that is where portion of 1.35 goes 0.64. So, dun sa 1.35, 0.64 pala yung discharge along pipe 2. So, ano lang yung natira na discharge sa pipe 3, which is 0.71. So, yun na lang yung natira. So, 0.64 and 0.71 is 1.35. Yun ang pinaghatian nung pipes 2 and 3. So, with Q3 known, we can solve for HF3 and that is 4.74. So, ang tanong sa atin, ano daw ang surface elevation ng water doon sa reservoir C? So, if this is given as 4.74, okay? So, yung elevation nito na na-compute natin na 147.82, ibawas natin yung 4.74, yun na lang yung elevation ng water surface sa C, which is 143.08.